All right, so in the last section we learned about implicit differentiation, and now we're going to kind of sort of take it a step further, and we are going to use implicit differentiation to find related rates. And so from problem number 1 in 12.4, first of all, we recognize that this is not a function because we've got an exponent on our y. And then my particular information I've already listed over here. So I was told that dx dt is 3, x is 1, y is 2. And so remember, when we take a derivative, we're looking at a specific moment in time if we're talking about time. Otherwise, we're looking at a specific point on the graph. So what we did with implicit differentiation is every time we took a derivative with y, we would put dy. And then every time we took a derivative of x, we would put dx. And along that line. Well, now we've introduced this dt. And this dt simply means how is x changing as time changes. So x is changing this way as time changes. So our process is going to be the same, but I'm going to wrap it up and kind of show you how it'll revert back to implicit differentiation. But basically, dive in, take a derivative. So the derivative of y cubed is going to be 3y squared. And then we would normally put dy, but since we're doing related rates, we're going to do dy dt. Okay, equals, and that just means how is y changing as time changes. Okay, this one is going to be 8x to the third dx dt, and then the derivative of 6 is 0. So if we look at this, I have a y variable, a dy dt variable, an x variable, and a dx dt variable. So I'm given 4 variables. And then in my particular stuff, to evaluate this thing, you'll notice I've got 3 of them resolved, which means I'm actually solving for dy dt. So if we look at number 1, it says dy dt is, and so we're finding dy dt. All right, so you can either divide both sides by 3y squared, or we can just go ahead and sub in information and then solve it from there. It doesn't really matter. You'll get the same answer. So I have a 3 times a y squared. Well, my y is 2. So 2 squared is 4. And then dy dt equals 8. My x is 1. So 1 times 1 times 1 is 1. And then dx dt is 3. So when I clean this up, I get 12 dy dt equals 24. And now when I solve and get dy dt by itself, I'm going to get 2. Divide both sides by 12. So dy dt is 2 because I divided both sides by 12. All right, so what does that mean? That means in this particular scenario, as x is moving in a positive direction, because 3 is positive, as time moves on, that means y is also moving in a positive direction, so it would be going up 2 in terms of t. Okay, now, I said I would resolve this thing, so here's the fun part. Hang on, I've lost my pencil. Where is my pencil? Where did it go? Here's one. All right, so we have, come back up to this part for just a second, because if I had asked you to solve for dy dx, which is what we were doing before, with just implicit differentiation, I would have a 3y squared dy dt equals an 8x cubed dx dt. And so I would divide both sides by 3y squared. So I've got dy dt equals 8x cubed over 3y squared dx dt. And now I can divide both sides by dx dt. So if I divide both sides by dx dt, that means dy dt over dx dt, which is simply a fraction over a fraction, or a fraction divided by a fraction, becomes dy dt times the reciprocal, which is dt dx. And dt's are the same number, because any number divided by itself is 1. So you solve, that ends up being on the left, dy dx. So we've kind of sort of been doing this the whole time in implicit differentiation, but now we're going to leave it in its more complicated state and keep those dt's in there. All right, so our next problem is, I'm going to do 5 of these, and then we're going to go to some word problems on the second video. All right, so our second problem is x squared plus 4y squared plus 6y is 14. And then the particulars that I'm given are dx dt is 1 when x is 4 and y is negative 1. Okay, so I'm supposed to find dy dt. So take the derivative here. The derivative of x squared is 2x dx dt plus the derivative here is going to be 8y dy dt plus this becomes a 6 dy dt equals 0. And so you have options because I'm done with calculus at this point. I can just go ahead and sub in and then solve for dy dt. Or you can organize everything up front. I think it's easier to organize after I've evaluated. So as long as the calculus is done, you can go ahead and evaluate now. So 2 times, what is my x? He's 4. So 2 times 4 is 8. dx dt is 1. So this is 2, 4, and 1. Plus 8 times my y is negative 1. So I get negative 8 dy dt plus 6 dy dt is 0. Well, if I try and get dy dt by itself, this is common terms. This is like terms. So I'm going to subtract 8 over, and then negative 8 of these plus 6 of these is negative 2 of these. So negative 2 dy dt equals, and I'm going to kick this one over, so he's a negative 8. And then divide both sides by negative 2. So dy dt is going to be 4. Okay, so again, I did the calculus. If you want to reorganize like what we were doing with implicit differentiation, you can. I personally think it's a lot easier as soon as calculus is done. Go ahead and sub in that stuff and it all falls out pretty. All right, so let's do another one. I'm going slightly insane being all by myself. All right, so I want to find dx dt. Hang on. Given that x times y equals x plus y, so xy equals x plus y, and then my values are, I'm trying to find dx dt, given that x is 5, y is 2, and dy dt is negative 4. So dy dt is negative 4. All right, so with that information, come back over here. What is your setup? I've got variables times variables, so I'm going to have to use product rule here. So I will have the first, which is x, times the derivative of the second. So the derivative of y is 1 dy dt, plus the second, which is y, times the derivative of the first, which is 1 dx dt, equals the derivative of 1x is 1 dx dt, and the derivative of y, sorry, that was my phone, is 1 dy dt. So again, I've got an x and a y. I got a dy, dx, dx, dy. I have everything accounted for except for the dx dt's, and I'm supposed to solve for dx dt. So my x is 5. dy dt is negative 4. Plus, this pen is crappy. Y is 2. dx dt is what I'm solving for. Equals dx dt is what I'm solving for. Plus dy dt is negative 4. Okay, so now I can just start organizing. Just remember that this is a value. It is a number. So all you're doing is combining like terms. So this becomes negative 20. 5 times negative 4 is negative 20. I was going to skip that and do one step, but I'm not going to do that. Plus 2 dx dt equals dx dt minus 4. So I need the dx dt's on the left so I can solve for them, and the constants on the right. So I'm going to add 20. So 2 dx dt's minus 1. So I'm going to subtract this one over. Equals, add that 20 over, minus 4. So I took this and subtracted it over, and I took that and added it over. Okay, so I just kind of sort of flip-flop those two things. Well, now what do we have here? I've got 2 dx dt's minus 1 dx dt is a single dx dt equals, and 20 minus 4 is 16. Okay, so again, what does this mean? This means as y is dropping, so my vertical change is a negative 4 at some rate of time, then my horizontal change is a positive 16 in some rate of time. Okay, so you're just looking at the individual components instead of just the slope of the change of y, change of x. All right, so we got 2 more, and then we'll go to word problems in part 2. So I've got, given that x to the third, I'm going to use a pencil. Given that x to the third plus y to the third is 54. So that's my function. And then my particulars are x is 3 and dx dt is negative 2. So x is 3, dx dt is negative 2. And so I want to find dy dt. Now, hopefully you've noticed that there's something missing, because so far I've been given an x, you can't see, an x value, a y value, and then one of the values of the derivatives, either dx dt or dy dt. Okay, on this one, I'm given one of the values of the variables, of the derivatives, but I'm not given y. Okay, so we'll resolve that in a minute, but for right now, let's get the calculus out of the way. All right, so my derivative here is going to be a 3x squared dx dt, okay, plus a 3y squared dy dt, and that's going to equal 0. Okay, so there's people in my front yard. All right, so here's the thing. I've got 4 variables. I've got x's, dx dt. I got y's, dy dt. But all I've got resolved up here is my x's. And my instructions are to find dy dt. Well, anytime you need to know an original value, go back up to your original equation. So if I need to know what y is, go back up to your original equation. So if x is 3, 3 cubed is 27. Okay? So 3 cubed plus y cubed is 54. So 3 times 3 times 3 is 27. So y cubed is going to be 27 because I subtracted 27 from both sides, which means y also must be 3. Okay? Y also must be 3. So I went ahead and found that original information just based on going back up to the original function. So now I got my x's and my y's and my dx dt. So going into solve, I've got 3 times my x is 3. So 3 times 3 times 3 is 27, and dx dt is a negative 2. Plus 3y squared, well, I figured out from the original equation that y is also 3. So 3 times 3 times 3 is 27. And I need to know what dy dt is. So this becomes a negative 54, so I'm going to add 54 to both sides. So 27 dy dt is a positive 54. So dy dt must be 2. Divide both sides by 27. Okay, and I got just enough time for the last one. So we have, and I'm going to speed this up, find dx dt given that x to the 4th equals 9y to the 3rd minus 8. Okay, and then I'm told that I'm finding dx dt, y is 1, and dy dt is 1. So dy dt is 1. So again, we should recognize that we're missing an x. So let's go ahead and find out what x is. 9 times 1 cubed is 9, minus 8 is 1. And any number, or sorry, 1 to any power is 1. So I also know that x is 1, and that's just pure algebra. Okay, take a derivative because I'm running out of time. 4x to the 3rd dx dt equals 27y squared dy dt, and 8 goes to 0. So these are both 1. Dy dt is 1. So what I have is a 4. Dx dt is 27. Divide both sides by 4, and I get 27/4. And that is it.